Hello students, welcome to our online open class. Today we will learn about the third operation of program design for various types of cavity parts. This process is the precision machining of the internal contour side walls. The process involves the deep machining, and we have adopted the UG depth contour machining method. Most importantly, we should pay attention to select steep inner and outer walls and corners as boundaries and incorporate layer-to-layer transitions in the cutting methods used for tool passes. We should adopt a hybrid process, prioritizing depth to avoid tool lifting. We should wisely choose the starting point of each layer and correctly prevent from overcutting the minimum safe distance. The cutting depth per tool pass is defined as 0.1 mm. The programming steps are as follows. First, create the process. This process uses the depth contour machining method. Specify the cutting area and set the tool path. Second, simulate the machining process. Please refer to the skill operation for details. Let's begin the skill operation demonstration for the internal contour side wall fine machining procedure. First, click the Geometry option and right-click to choose Insert. Then navigate to the Procedure section. In the Procedure, choose Depth Contour Milling and select a tool with a diameter of 8 mm along with Geometry B. Set the method to Fine Machining and name the process Internal Contour Side Wall Fine Machining Procedure. Then click OK. Next, specify the cutting area using the Face Geometry method. Switch to the top view using Ctrl, Alt, and T keys. Switch to the top view and frame select all upper surfaces. Exclude the unnecessary surfaces by holding down the Shift key. After the selection, return to the side view and click OK. The step distance is set to 0.2 mm. Click the Cutting Parameter Settings. Change the parameters to Mixed Depth Priority and check rolling the tool on the edge, setting the allowance to 0. After completing these settings, click OK. For non-cutting parameters, adjust both the entering and the retracting of the tool to spiral down, and set the open area to arc entry and exit. Click OK. Click on Generate, and once the toolpath calculation is completed, click OK again. Then select the corresponding procedure. Right-click on Toolpath and click OK. Adjust the animation playback speed to 3 and start the playback. It's important to note that computer-assisted programming does not include clapping information. In the process of depth contour milling, the cutting direction and order usually follow the principles of mixed depth priority. Direct entry onto the part is not recommended during depth contour machining. CNC stands for Computer Numerical Control. In the method of depth contour milling, if each layer's tool path is not enclosed to improve production efficiency, a sequential method can be adopted. Accelerate simulation running speed. After the playback, click OK. Then select the procedure. Right-click to find the post-processing. Choose the corresponding post-processing file, set it to metric or imperial, and click OK. After clicking OK again, overwrite the original file, thus the machining program is generated. Depending on the equipment requirements, the program can be modified and optimized as needed. The skill operation is now complete. Depth contour milling. 1. Tool path setting. Depth contour machining operation is a special example of cavity milling, which is often applied to the finish and semi-finish machining of steep surfaces. Compared to cavity milling, it adds some specific parameters such as steep angle, milling menu, interlayer transition, and layer segmentation. Second, connections and strategies are important parameters for depth contour milling. Third, non-cutting movements and feed consist of closed and open areas. Types in both areas are the same as in the open areas. Spiral, inclined along shape. Plunge, with 5 ways in total. We generally use spiral feed and ramping. Today we completed the third operation of cavity part program designed on the UG software platform. During the programming process, we used the depth contour milling method. Now you can practice based on the operation demonstration. Use a hybrid and depth-first strategy to avoid tool lifting, thus improving machining efficiency. Please set parameters reasonably and optimize them in the program. Thank you for listening.